Okay, in this video, we're going to go over some trig ratios, SOHCAHTOA review. You should have seen this in geometry, so I am going to go a little fast and assume that you know a little bit more than just nothing. So trigonometry is based off of some ratios, and these ratios are sine, cosine, and tangent. So sine, in case you recall from last year, sine is the ratio of opposite over hypotenuse. Cosine is the ratio of adjacent over hypotenuse. And tangent is the ratio of opposite over adjacent. And that's where you get the SOHCAHTOA. It's unfortunate because when you remember SOHCAHTOA, everyone just remembers SOHCAHTOA. They don't remember the opposite, hypotenuse, adjacent definitions for those things and what we're even talking about. So a trig ratio basically gives you this sine or cosine or tangent, which is a function, a formula, something that takes something in and does stuff to it, kind of like a log from your previous unit. And in this case, it works with angle measurements and sides of right triangles. So whenever I say opposite, adjacent, hypotenuse, I'm talking about sides. Whenever I'm saying angle measurement, or in this case, this is called a theta, I'm talking about measurements of angles. So in this case, theta is really calling the reference angle. So these are working with right triangles, but theta is not the right angle. So we're going to write that down. It's a reference angle. Remember, this is the notation I'm going to use for angle. Theta, this funny thing, it's a Greek letter, so it's actually just a variable. We like to use Greek letters to symbolize angles, and we like to use American letters? I don't know if that's what that's called. I don't teach English. I don't know. To represent measurements. So this can be any angle in the right triangle except the right angle. So we find out which side is the opposite, adjacent, and hypotenuse by going off of this reference angle. So the opposite side is the side across from theta. The adjacent side is the side that is next to theta, but not the hypotenuse. And remember, the hypotenuse doesn't change on a right triangle, even if theta changes, because the hypotenuse is across from the right angle. I like to identify the hypotenuse first because then it leaves the adjacent side to be the other one next to the theta. So we're just going to really quick identify what is a hypotenuse, adjacent side, and opposite side of different triangles with a theta. So, like I said, I like to identify the hypotenuse first. So if this is the right angle, here's the hypotenuse. If this is the reference angle, then across from it is opposite. And then next to it is adjacent. Do you see how sometimes if we don't do the hypotenuse before we do the adjacent, we have two sides that are next to the theta and you get confused. So if you do hypotenuse because it's across from the right angle first, you only have one side next to theta. So again, right angle, hypotenuse. Reference angle, opposite. Guy that's left, next to theta, adjacent. Right angle, hypotenuse. Reference angle, opposite. Guy that's left, adjacent. You flip the page, now it's going to say set up each trig ratio. So before you set up a trig ratio, you're going to want to identify the sides again. So we have the right angle, so this is the hypotenuse. This is the opposite. And this is the adjacent. You're going to want to start almost every trig problem by identifying which side is which. it's just easier to work with instead of eyeing it up and then forgetting. So in this case, sine is opposite over hypotenuse, so it's 3/5. Cosine is adjacent over hypotenuse, so it's 4/5. And tan is TOA, opposite over adjacent, so that's 3/5. 4. Notice the next problem is the same exact triangle, but I wanted to show that theta can change. So if theta changes, your ratios change because it changes the location of the sides. 5 is still the hypotenuse because it still didn't move across from the right angle. But now 4 is my opposite because 4 is the leg across from the reference angle and 3 is the adjacent. So my trig ratios change here. So if my sine of theta is going to be opposite over hypotenuse, which is 4/5. Cosine is going to be 3/5. And tangent is going to be 4/3 because it's TOA opposite over adjacent. This should be a 3. Sorry, I'm sloppy. All right, so there was your quick trig review.